Welcome back. We are diving directly into part 4 of our discussion on rational functions. We are pretty much done with the training wheels. This is where we get into some real serious business, full-bodied examples. Gloves are off. So I'm going to throw us directly into a function. We'll say y equals, let's go, x squared minus 2x minus 15 divided by, let's do 3x squared, negative 3x squared plus 12. We'll be super adventurous about this. We'll just go nuts with it. So, again, first thing I'm going to do is just start factoring this. Factoring it is going to help us out a lot in the long run. The top is a quadratic. It looks like that thing is going to factor into an x minus 5 and an x plus 3. The bottom, we can pull a 3 out. In fact, I'm going to pull the negative 3 out. What's left will be an x squared and a minus 4. X squared minus 4, I hope everyone remembers, factors into an x plus 2 and an x minus 2. So this is our fully factored rational function. This is going to help us out a lot. Now we can just start listing off various pieces of this thing. Like, I like to start with x-intercepts. X-intercepts come from setting the top equal to 0. So right away I can pretty easily see that they should be x equals 5 and negative 3. But I'm not going to record my answer as x equals because these look like asymptotes. I'm going to say 5 comma 0 and negative 3 comma 0 are my x-intercepts. I'm actually going to put that further over here. 5, 0, negative 3, 0. These are my x-intercepts. I'm going to erase the middle, that's why I want them on the edge. Next up, I need switch colors so that there's some clear delineation here. I'll do domain restrictions next. DRs for domain restriction. These come from setting the bottom equal to 0. And again, if it's factored, you can pretty easily see that this should be x cannot equal negative 2 or 2. And so this one is going to have two asymptotes. X equals 2, x equals negative 2. These are my vertical asymptotes. For y-intercepts, I need to set x equal to 0. For the x-intercept and the domain restriction, because we're setting pieces of this whole thing equal to 0, like here we set the top equal to 0, here we set the bottom equal to 0. When you're solving these guys, it's best to look at the factored form. Because you're setting it equal to 0. You're setting polynomials equal to 0, you want them to be factored. So the factored form is what we use for these two. For the x-intercept, it's easiest to come back to the original unfactored version. If you're setting x equals 0, all you have to do is look at the back end here and see that negative 15. Yeah, that's a terribly drawn 15. Negative 15 on the top, 12 on the bottom. Which simplifies into 5/4. We pull out a 3. Negative 5/4. Okay? And again, this is a point. So I'm going to say the point is 0, comma, negative 5/4. So just a little bit below negative 1. And lastly, I'm going to need some end behavior. The end behavior here is going to look like y looks like x squared from the top, negative 3x squared on the bottom. The x squareds cancel, we're going to get negative 1/3. If y equals negative 1/3, It means we have a horizontal asymptote at negative 1/3. So, this is all the information I need. I can create a coordinate axes and start graphing. Put 3 down there. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay. This looks like a good start for my axes. I'm going to start putting points on it. 5, 0 should go right here. Negative 3, 0 will go right here. 0, negative 5/4 is we said that's a little below negative 1. Those are my 3 intercepts. Right now, I need some asymptotes. Vertically, I'm going to have an asymptote here at x equals negative 2. And I'm going to have another one here at x equals 2. And horizontally, I just have this negative 1/3 business. Scooting across the graph a little below the x-axis. So this is all of my information. I have 2 vertical asymptotes. I have 1 horizontal asymptote. I have a handful of points here. So this is where we get to play a very interesting game of connect the dots. If we have 2 vertical asymptotes that cannot be crossed, that means that we need to have 3 basic chunks of this graph. We're going to have a left chunk of this graph to the left of the first vertical asymptote. We're going to have a right chunk of this graph to the far right of all the asymptotes. And then there's going to be a middle chunk. And none of those chunks are going to have pretty much anything to do with each other. You can't cross these asymptotes, so they're going to be completely separate. I'm going to start from the left again. I like to start at the far ends of this graph. To me, the clearest thing about this graph is the horizontal asymptote. This is its end behavior. I know that when x is really, really, really big, the function is going to look like this line. So it's going to come in near this line. I'm going to cross there. If I've already crossed here and now I need to look like this vertical line, I'm going to keep going up to get there. On the far, far right, I'm going to do the same thing. Coming in at the extreme right, it's going to look like this flat line. It's going to cross here. If I'm above the axis and I need to look like a vertical line, I'm going to keep going straight up. The middle is going to get very interesting. This is the only point I have in the middle right now. And I need to decide, as I move to the left, to the right, and to the left, I need to decide whether it's going to go up for this asymptote or whether it's going to go down for this asymptote. And same over here, whether it's going to go up like this or down like this. One way to do this is just to pick some points. You could plug in 1, find a value, plot that point. You could plug in -1 to this equation. You find a value, you plot that point. You get a couple extra points. It tells you about what the graph is doing. It's a handy trick. You don't have to do that, though. You can kind of process of elimination this. There's only 2 options here. You're either going to turn up or you're going to turn down. If you turned up, you would have to cross the axis here. And you can't cross the axis here because there's no intercept. This list of intercepts with the -3 and the +5, That is an exhaustive list of intercepts. Those are the only two places it crosses the x-axis. It cannot cross the axis over here. So you can't go up. You're below the axis, you need to stay below the axis, you gotta turn down. Same on the back end. You can't turn up, you've gotta turn down. For what, I am told. This is the graph. We got the horizontal asymptote on the back end, doing the T-pose technique. Horizontal asymptote to the left, horizontal asymptote to the right. That's at -1/3. We got our intercepts here. It's going to turn up from these -1/3 to catch these vertical asymptotes here. In between the asymptotes, kind of looks like an upside down parabola, except parabolas always get wider. This thing does not get wider. This thing is very squished. It exists strictly between +2 and -2. Never gets bigger than that. It goes straight down, like a line, from there. That's the end of this example. There's exactly one more example I want to do, so we're going to get into part 5 in just a moment, after I cut this video and erase this whiteboard.